Hey, this is a video for 5.3, the Green Revolution. So go ahead and check out the overview and set up your guided notes. So if we look at the human population over time, along with the food production over time, we would see that the human population has shown exponential growth, reaching the biotic potential. It still hasn't leveled off yet, so anyone's guess for how high this could go. The food production, however, has shown arithmetic growth. And there could potentially have been a problem where the human population overshot our food production, and that could have been a crisis. And this is an idea that was proposed by Thomas Malthus. You don't have to remember his name. He had a lot of great ideas, but this is something that he brought up. But something happened to improve our food production. So this happened in the 1950s, and is there potential for another crisis? Well, that remains to be seen. So what happened was we had a green revolution, and that was the shift in the 1950s in agricultural practices that improved the yields. Now, you might think that this shift was a good thing. Some of the stuff was good for feeding the human population. However, environmentally, we have found out later that it's actually a lot of these practices are very detrimental to the environment. So pretty much everything that we talk about during this video is bad for the environment. So the first step, or the first practice that was introduced in the Green Revolution, is mechanization. And mechanization is when we use machinery in order to plant, maintain, and harvest crops. Now, a plus is that it is cost effective, it is very efficient, but we have a few cons: fossil fuel use, and we will compact the soil, which can impact the water holding capacity. It can decrease the water holding capacity because there's not a lot of pores in the soil once you compact it. Also, it can lead to soil erosion because that water's not able to infiltrate the soil. We also had monocropping, and monocropping is planting one type of crop in the entire field. Now again, this is very efficient. You can get higher profits, you can increase your yield. However, you have to harvest these plants all at the same time, and that would lead to bare soil. And when you have bare soil, you're susceptible to rapid evaporation, and you're also susceptible to soil erosion. It would also You're removing the same soil nutrients. And when we're talking something like this crop, corn is a nutrient hog and a water hog. So it's going to be very detrimental to the soil if you keep taking out the same nutrients over and over and over again. And also, these crops, since they're all the same, they're going to be susceptible to disease. So especially if you don't have a lot of genetic diversity in the corn, and why should you? It's all the same plant. And a lot of them are coming from, last season's corn. You just plant a couple of cobs and you get a lot of kernels and you plant them all. So yeah, it's a lot of inbreeding probably, and they will be very susceptible to disease. So another one, and one way that this has been added later, is using genetically modified organisms. This wasn't in the 1950s right away, but genetically modified organisms oftentimes shows up with monocropping. And that's when we are altering the DNA of the agricultural crops in order to produce specific proteins. And most notably, we're using DNA from to provide pest resistance. So they may have pesticide resistance, or they may be resistant to the actual pest. Problem is these seeds that are produced are owned by the agribusiness company. So if your corn, if your soybeans produce, you can't use those seeds for next year's crop because they're technically owned by the people you bought the seeds from. And that's kind of an ethical issue. But also, we don't really know the long-term effects of these genetically modified organisms because the technology hasn't been around, for more than 50 years. Now, because we're taking out the same nutrients over and over and over again, scientists and farmers have developed synthetic fertilizers, and these are inorganic nitrate and phosphate solutions. A lot of times you'll use ammonium nitrate, which is NH4NO3, and that is a lot of nitrogen that's being added. So it is providing a lot of key nutrients. However, these nutrients are not held because they're inorganic. They easily will wash away, and they will can easily enter a waterway, which can lead to, when there's runoff, it can lead to eutrophication. Remember, eutrophication is the addition of nutrients to a body of water, leading to an algal bloom, which eventually the plants will die, and the bacteria decomposition will use up all of the oxygen, leading to hypoxia and biodiversity loss. But also with synthetic fertilizers, you have to make them in a laboratory, and you have to distribute them to the crops, and that takes a lot of fossil fuels. We also must irrigate our crops. This is a sprinkler irrigation system. But irrigation is just applying water. There's many different techniques. We'll talk about all of these practices in future videos. But irrigation is increasing the amount of arable or farmable land. So it could take some areas that may not have had a lot of water, like especially Central California. There is an area where it is highly productive, but it is using an incredible amount of water. And it will also increase productivity because you're not just left to rain like natural rain. Some areas have rainy and dry seasons. Now you can plant crops. You don't have to worry about external rain from the atmosphere. But negatives, we're depleting aquifers. We're using up all of the water from the groundwater, but can also lead to waterlogging and soil salinization. And both of these we will talk about in a future irrigation video. We also need to use a lot of pesticides because we have the same crops. If there's a disease that hits one corn plant, for example, it could affect all of the surrounding corn plants. Or there could be an insect that affects all of the corn plants. So we need to use pesticides and other chemicals in order to remove these pests. And it's good because it's preventing the destruction of an entire field of crops. However, you can also harm non-target species like bees and pollinators. And other things, in the past, we've used DDT, which is an insecticide, and that built up in the tissues of organisms and ended up almost wiping out our bald eagle population. Again, these will be discussed in future videos. Now, we're using a lot of energy in the United States in order to produce our food. In fact, for every calorie of food that is produced, we're using 10 calories of energy. And that's coming from fertilizers, pesticides, machinery, irrigation, and transportation or delivery of the food. So we have a much bigger expenditure. We're putting in way more energy than we are getting out of it. Now, we do provide subsidies. Subsidies is money that is given by the government for particular amounts or for particular types of food. So this is the recommended amount of sugar, oil, starch, and alcohol recommended by the federal government. This is the amount of recommended fruits and vegetables. The amount recommended of proteins, that includes meat, but also dairy, nuts, and legumes. Remember, legumes are like beans and peas, like soybeans, for example. And the amount of grains. So this would be from corn to wheat to rye, barley, all of that. This is the amount that the government is providing. So this is what they recommend, but here's the breakdown of how much the government is giving. This is how many subsidies. So a lot of the money to raise sugar, oil, starches, and alcohols is given by the federal government, way more than we need in our daily diet. Very little money is given to fruits and vegetables, which is a complete travesty because with an unhealthy population that we have, we definitely need to have more money so fruits and vegetables can be cheaper and more easily obtainable for all people. Giving a huge amount of money, way too much money, to protein production. And a lot of this is for beef cattle and meat production. And we're going to talk about the whole issues regarding meat production in a future video. And we have a very small amount of subsidies given to grains. And these grains, a lot of them, shocker, it's corn, and the corn is being used to, guess what? Feed the cows. So 3/4 of our federal subsidies, the money that's given to farmers, is given to farmers favoring meat production, which is kind of sad. What I would like you to do is respond to this check for understanding. And we're going to practice the FRQs. I want you to describe one human and one environmental impact of mechanization. I hope that this video was informative. I thank you for your attention, and I will see you soon.